hey, I kind of want to hack my car. And when thinking about what technical things I could do with a car, Tesla's definitely come to mind. Now, don't get me wrong, autopilot is pretty cool, but clearly the best part about Teslas is being able to play Beach Buggy Racing 2 from right inside the car. So I'm gonna hack my car and play Mario Kart with it. To give a bit of an explanation on how cars work, they're becoming more and more like computers on wheels. It's essentially a connected set of systems that work together to make it all happen.
There's a ton of modules in there, like the power steering control module, the GPS module, the parking aid module, and many, many more.
This means that these systems and modules need to talk to each other somehow. And to do this, they rely on one or more CAN buses. The way CAN networks work is by emitting and listening to events that are continuously being broadcasted throughout the network. These go from informational events like the current speed and the steering wheel position, all the way to commands like engaging cruise control. In a lot of cars, they make these CAN buses available on the OBD2 port so that mechanics can diagnose and fix issues that might be going on with the car. But luckily for us, this means that we can hook into that port and listen into these messages that are being sent through the network.
So meet the Panda. This gives you access to the many communication buses of your car and is pretty much built for car hacking. If we go all the way down here, you will see the OBD2 port. You just have to hook this guy in there and we should be able to see stuff.
Just looking at these random messages that are coming in is going to make it really hard for us to figure out what's actually going on. The people that make the Panda also provide an app called Commaai that makes it much easier to poke around and figure out what's going on in the CAN bus. So with that said, let's get started. I found a paper about car hacking that actually uses an older model of this same car, and it has some example messages that they've identified. According to that paper, on address 351, we should get the accelerator pedal.
So apparently this, I think we found it.
As soon as I press it, this value changes. I'm not sure what unit the pedal is in, but I don't think that's really important because all we want to do is really detect if it's pressed or not. Address 200 has some RPM related stuff, but then we get a bit field on whether the brake is pressed or not, and it's a simple 0 or 1. So if we look at that address, this should be brake, I think. If we press the brake, it actually goes to 1. And then if I let go, you can see it goes back down to 0. Okay, so we know that works. And now I kind of want to get the steering wheel. According to this, XX, YY describe the steering wheel position. This is some sort of position 1. I'm gonna just give this a little turn. Oh, I do see the numbers turning, or changing rather. So if I map out position 2, we can actually see when I turned the wheel, apparently one way it goes over 20K. I'm not sure what unit this is in, but it is telling me something about the steering wheel. We can definitely use this as inputs as well. So we've kind of figured out most of the messages we need, but I wanted you to be able to see what I was doing with the car. So I want the steering wheel here. Oh my God. And I want it to turn, and then I want the brake and the accelerator to indicate when it's pressed. I think that's it. How do I make a GUI with Python? Bruh, give me some HTML. Do HTML all day. Okay. So we have the demo UI running, but now we actually need to hook it up. So instead of this app reading everything, we need to make our script read the CAN bus and look for these message IDs. The pedals one should be simple, so I guess we'll start with that. We're gonna receive on the CAN bus, and then we're gonna do if the address is 200. If we have the byte array, we can look at the index 6. Okay, ready? Okay, it works. Right now it's just spamming a bunch of zeros. But as soon as I press the brake, they all go to 1. I'm gonna do the same thing with the gas. We're gonna do the 7th is greater than, I don't know, let's say 5. Okay, that's great, that's great. So now we have to do the steering wheel, which I guess is gonna be a bit trickier. Let's just try and log the data first. Okay, so we are seeing the numbers change. And I'm just gonna get the 3rd and 4th byte, I guess. Okay, what if we make a new byte array? Int.from bytes, and we do steer position? Okay, so we're getting a number. Oh wait, that's a number that we were seeing in Cabana. And what it seems like, it has an offset of 20,000. So if we subtract 20,000, that might be right. But it's really sensitive. Or maybe there's a factor? What if I multiply this by 0.1? Oh wait, that's actually right. So there appears to be a 20,000 offset, and then if I multiply it by 0.1, we actually get an angle. Because if I turn to the right, like 180 degrees, the angle is 187 or so, which that's right. And then if I turn the other way, I also get 180 or so. That means we have an angle. Yes. Okay, great. So now I'll wire this up to the UI that we made earlier. Unfortunately, there's not really any other inputs that we can use that are available on the CAN bus for drifting and triggering power-ups. So I had to come up with another way. I had these arcade buttons laying around, and if I could mount them somehow to the steering wheel, that could do the job.
Okay, so let's talk about how all these things work together. First up, the Panda is going to read all the CAN messages from the car and send them to our laptop. The laptop's going to be running a script that listens for the specific messages we need and turns them into button presses, as well as draws them to a UI. That goes out through serial to an Arduino MKR1000. The Arduino takes these serial messages and converts them into controller inputs that the Switch can understand. In the previous video, I talked a bit more about how this works, but essentially it can make itself look like a Nintendo Pro controller to the Switch. We also have these steering wheel mounted buttons that are connected to the Arduino, which turns them into L and R button triggers for the Nintendo Switch as well. Finally, the Switch just runs the game normally. Make sense? Cool, let's try it out.
So I plugged everything in and it should be working. The wheel is turning, and if I press the accelerator, we see that A comes up. I press the brake and B comes up. I press these buttons, R and L come up. I think we're ready to play. Okay. Oh my God. I didn't think, oh God, the RPM on my car is going crazy. Okay, wait. Instead of going forward with the gas and backwards with the brake, I'm gonna do forward with the brake and backwards with the gas, because I don't wanna be like revving up my car when it's parked like this. Okay, let's try this again. Here we go. Yes. Okay, this feels a lot better. I'm just bad. Okay, I can drift. Terribly. Okay, third. Not bad. Not bad. It's kind of hard to get used to it. Everything's working though. First place, right off the bat. Oh God. Okay, we're kind of losing it. Kind of losing it. Not gonna lie. Oh no. Still have a lap to get it back. Oh God. Yeah, I'm not gonna get it here. Okay, second. We're doing better. We're doing better. I think we got third on the last one, second on this one. We're gonna get first on the next. Hopefully this race is done before my computer runs out of battery. I can't see. Nope. No, the camera! The camera turned off! Okay, I got third place anyway. I need my battery's 1%. Yeah, my computer died too. Only my phone is left. Overall thoughts, I think it's kind of fun. It's more immersive, I feel like. I was ducking when the thing was gonna fall on top of the car. It's kind of hard to get used to, but it works and it's fun. I think we accomplished our goal. Okay, we're done.
Is this thing recording?